Good morning everyone, welcome to the question number 4. This is homework portal week number 5. Okay, now let us start this particular problem. This problem is on gravitation. Okay, this problem is for 12 marks, so let me keep the timer at 12. Okay, let's start. One evening you observe a point of light moving steadily across the sky and tell your friends it's a satellite. Okay, this is a satellite. You are standing here. One of them asks how long will it take to go around the earth and come into the view again. Okay, so how long does it take? Being a physics student, you work it out from the first principles, explaining as you go. Having no pen or paper, you estimate the values mentally to 1 or 2 significant digits. Okay, fine. Orbit and force. The diagram shows the satellite moving in orbit around the earth. Show and label any forces acting on the satellite at the position shown. So what is he asking here? Show and label any forces acting on the satellite at the position zone. What are the forces acting? State what exerts the force. This for 2 marks over here. So the first force that acts on it is nothing but your gravitational force, which you call it as G capital M small m divided by r square, which can also be said something like this, your centripetal force, Fc. Okay, state what exerts the gravitational force. So centripetal force is being absorbed because of the gravitational force. That's your answer. Then force exerted on satellite is nothing but gravitational force, right. Then orbit radius. You know that the low orbit radius are nearly circular orbits are a few hundred kilometers above the earth's surface, few hundreds of kilometers. Okay, I'll do one thing. Let me take this hundreds of kilometers, this statement to be between 100 to 500 kilometers. Okay, so I can take any value, right? Because until unless it's not given, I can't do anything. You do not remember the radius of the earth, but recall that historically the meter was defined. So the distance between the arc between the equator and the pole of the earth was 10,000 kilometers. Distance between the arc. Okay, this is the earth. So this is the pole, north pole, south pole over here, and equator is somewhere over here. This is your equator, which passes in between. Okay, it says the distance between the arc, along the arc between the equator and the pole of the earth, equator and the pole of the earth, this distance, okay, is seen to be 10,000 kilometers. 10,000 kilometers. Okay, so this small curve from here to here, 1/4 of the circle, what you see here. Okay, so the radius of the circle's orbit is approximately 6 into 10 power 6 meters. So you need to show the radius is so much. Now what we do is, if this is 1/4, then the whole circle would be 4 quarters, right? So which means the whole circle, which you call it as the circumference, is 4 quarters. So circumference should be equal to 4 quarters, which should be 4 into 10,000, which should be equal to 40,000 kilometers. This is 40,000 kilometers. Now what do I need? I need radius. How do you relate radius to the circumference, which is nothing but, if this is the radius r, this is what you need to find. So c should be equal to 2 pi r. Simple. So substitute this. 2 pi r should be equal to 40,000, and then r should be equal to 40,000 divided by 2 pi. Let us use our calculator to find whether we are getting the correct answer. So which should be 40,000 divided by 2 is equal to so much, divided by 3.14 will be 6,369. Wow, 6,369 kilometers. What is the actual answer? The actual answer is 6,400 kilometers, right? So therefore, somehow we have got the correct answer for the radius of satellite orbit, and approximately this is 6 into 10 to the power of 6 meters. How is it? So this can be written as 6 into 10 cube into 10 cube meters, right? Which should be 6 into 10 power 6 meters. Okay, so this also we have solved. Next question. Satellite accelerations. You decide to take the acceleration of the satellite in its orbit as the same as the gravitational acceleration of a stone dropped near the surface of the earth. What is the acceleration of a stone dropped near the surface of the earth? This should be g is equal to 9.8 or nearly 10. Okay, that's approximately 10. Oh, it's already given. Justify why it is a good approximation even though the satellite is not at the surface of the earth but several hundred kilometers up. Okay, I told you earlier also that if it is several hundred kilometers, maybe I will choose this as a 100 to 500 kilometers is my distance. Now we know the gravity at this height could be given by, or any height is given by, g is equal to gm by r square. Okay, so it's a 4-mark question, both the questions together. So let me do some math over here to understand. So what I do is, let me take the fractional value of g, delta g by g is equal to g and m is constant. This should be 2 times delta r by r. Okay, now delta r, what is delta r? Delta r is nothing but the change in the value of r, which could be around 100 to 500 kilometers. Let me choose 500 kilometers only. Okay, so which should be 2 into 500 kilometers divided by, what is the value of r which we have found out, which is around 6 into 10 to the power of 6, right, meters over here, meters. So if I do this one here, I get this as 10 cube into 10 cube, this is for 10 cube here, this 10 cube here, divided by 6 into 10 power 6. This goes away, so you get 1/6 of it, right? So delta g will be equal to 1/6 of g. That means the variation here, what is 1/6? 0.167 should be your g. Okay, so the value of Vg can vary of the order of only 16% of it, which is really very, very small, even though I consider to a distance of 500 kilometers. Usually these satellites, which you say it is visible through the eyes, it will not be at a height of 500 kilometers. It would be of the order of some 100 to 200 kilometers, not more than that. So therefore, definitely this approximation serves to be a good one. So therefore, we can justify that the value of g does not change much over here. Okay, what is this delta g? Delta g is nothing but g minus g dash, right? So or g dash minus g, whatever you take, g dash minus g. Okay, so therefore, if you consider what is delta g over there, it sees that there's a change in the gravity between the gravity that you see there and the gravity that you observe on the earth, which is really very small, which is of the order of 0.167 times the actual value of g. So as a result of it, even if I take this g to be, the distance to be 500 kilometers, this is what I get. If I take it to be 100 kilometers distance, okay, so what will the answer be? If I take it 100 kilometers, the answer would be, let me do it here, which would be 2 into 100 kilometer divided by 6 into 10 to the power of 3 kilometer, which now kilometer goes away, and this is 200, so this and this goes away, so you get 2 by 60, which is 1 by 30. 1 by 30 is very, very less, right? So therefore, there's no point in considering this. So, and hence we see that the acceleration due to gravity on the surface of the satellite, or at the orbit of the satellite and on the surface of the earth, is nearly the same. Okay, let me move further. It's of different mass to the stone. What does it say? Justify why this is a good assumption, even though the satellite is not on the surface of the earth and it's of different mass as compared to the stone. See, when you talk about the value of g, g is given by gm by r square, where m is the mass of the earth over there. Okay, and there is no value of this mass. Which mass is this? The mass of the satellite. Mass of the satellite does not come into picture at all here. So therefore, it does not depend upon the mass of the satellite or mass of the stone. So and hence it is directly dependent only on the mass of the gm by r square, mass of the earth, and as well as the distance between the center of the earth to the particle or to the satellite. Okay, now next one, satellite speed. Using the estimate the speed of the satellite. How do you estimate the speed of the satellite? Speed of the satellite is given by the orbital speed, which should be equal to square root of gm by r, right? R can be also be written as square root of g into r. Okay, gm is equal to gr square. When I substitute this, okay, I get root of gr, which should be square root of 9.8 multiplied by, what is the distance we have taken? We have taken something like 6 into 10 to the power of 6. So when I do this, let me do this to get the correct answer, which should be 9.8 star 6 is equal to 58.8 root of 58.8 into 10 to the power of 8 is plus 6, which should now be, take the square root of that. Square root of this one will be 7.66. 7.66 into 10 to the power of 10 power 6 whole half is nothing but 10 cube. So meter per second, this is nearly 7.6 kilometer per second. This should be your satellite's orbital speed. Okay, then next, orbital period. So what you have, hence answer your friend's question, how long will it take before the satellite comes back to it? Okay, orbital period t is equal to circumference divided by the speed of the satellite. Total distance traveled by, total distance around this earth is circumference divided by speed of the satellite, orbital speed, which should be, what is the orbital speed here? Now first what we will do is, let us see what is the value of g we have taken earlier. And doubtful the value of G, we have not taken any value of G. Okay, we can use this itself. So which was around, what is 2 pi r? 2 pi r, we took this as around 40,000 kilometers, right? So this was taken as 40,000 kilometers divided by, what is this, 7.6? This is kilometer. This is 7.6 kilometer. When I do this, what is the answer I get? We get this as, it's 7.66, I'm sorry, 7.7, 7.7. So I get the answer as 40,000 divided by 7.7. I get the answer as 5,194. 5,194 unit. This should be kilometer. This will be kilometer. This is kilometer per second, right? So therefore this should be seconds. But what is the question here? Answer in minutes. Two marks over here. So what should I do? I should divide this by 60 once again to get it in minutes. So whatever I got here, divide this by 60. I get this as 86.58 or nearly 87 minutes. 87 minutes. This should be your answer. Okay. So the answer says, marking scheme says it should be between 80 to 90 minutes. So 87 minutes is fairly correct. So therefore, this is the answer here. Okay. So with this, we come to an end to this problem. Tomorrow we will see with a new problem. Thank you.